Lesson: Integrating and organizing data for preprocessing success. Integrating and organizing data for preprocessing success is a critical competency for supply chain analysts aiming to leverage AI effectively. The process involves systematically gathering, organizing, and refining raw data into a clean, useful format to feed into AI models that enhance decision-making. Effective data preprocessing not only improves model performance, but also ensures more accurate predictions and insights, thereby streamlining supply chain operations. Data integration is the initial step in preprocessing, where data from various sources is combined into a unified view. This step is crucial as supply chain data typically emanates from disparate sources, such as ERP systems, CRM databases, IoT devices, and external market reports. The challenge lies in the heterogeneity of these data sources, often characterized by differing formats, structures, and semantics. For instance, ERP systems might store transaction data in structured SQL databases, while IoT devices generate unstructured or semi-structured data streams. To tackle this, tools like Apache NiFi or Talend are invaluable. Apache NiFi, for example, offers a robust data flow management system capable of ingesting, transforming, and routing data across various sources and formats. By employing such tools, supply chain analysts can automate data ingestion and ensure a consistent data structure is maintained. Once integrated, organizing the data is the next step. This involves cleaning and transforming the data to enhance its quality and usability. Data cleaning addresses issues like missing values, duplicates, and outliers, which, if left unaddressed, can lead to skewed insights and poor model performance. Techniques such as imputation for missing values and anomaly detection algorithms for outliers are crucial. For instance, case studies in the retail supply chain sector have shown that imputation methods, such as k-nearest neighbors, significantly improve inventory forecasting accuracy by filling gaps in sales data. Data transformation is another aspect of organization that involves converting data into a suitable format for analysis. This often includes normalization or standardization, which ensures that features contribute equally to the model's performance. In practice, normalization techniques have been shown to enhance the convergence speed of machine learning algorithms by ensuring that data scales do not disproportionately influence the model's learning process. The use of Python libraries like pandas and scikit-learn facilitates these tasks. Pandas provides powerful data manipulation capabilities, while scikit-learn offers preprocessing functions like min-max scaler and standard scaler for normalization and standardization, respectively. Having organized the data, the next step is feature engineering, which involves creating new variables or features that can enhance the predictive power of a model. This step is highly context-dependent and requires domain knowledge to identify which features might be relevant. For instance, in a supply chain context, features such as lead time variability or supplier reliability scores can be engineered to predict potential disruptions. Practical tools like feature tools can automate this process by leveraging deep feature synthesis, which constructs new features from raw datasets. Research has demonstrated that feature engineering can significantly improve model accuracy, with some studies reporting up to a 30% increase in predictive performance in supply chain risk management applications. Moreover, the integration and organization of data are not one-off tasks, but continuous processes that require ongoing monitoring and refinement. This dynamic nature is due to the ever-changing data landscapes and the introduction of new data sources over time. Implementing data pipelines using frameworks like Apache Airflow can help manage and automate these processes. Apache Airflow allows for the scheduling, monitoring, and management of complex workflows, ensuring that data is consistently updated and ready for analysis. By maintaining an automated data pipeline, supply chain analysts can focus on deriving insights rather than being bogged down by manual data management tasks. In practical terms, a case study involving a global logistics company demonstrated the effectiveness of these techniques. The company faced challenges in integrating data from its transportation management system, warehouse management system, and external weather data for predictive analytics. By employing Apache NiFi for data integration and Apache Airflow for managing their data pipeline, they streamlined their data preprocessing operations. Furthermore, using Python's pandas and scikit-learn for data cleaning and transformation, they improved their delivery time predictions by 20%, thereby enhancing customer satisfaction and reducing operational costs. Overall, integrating and organizing data for preprocessing success involves a series of methodical steps and the application of practical tools and techniques. By systematically addressing data integration, cleaning, transformation, and feature engineering, supply chain analysts can build robust AI models that drive efficiency and innovation. The continuous monitoring and automation of these processes ensure that data remains a reliable foundation for AI-driven insights, ultimately enabling a more responsive and resilient supply chain.